Hi everyone, and welcome back to this tutorial on building a Linux from scratch system. Now in the last videos we have already prepared our USB key, formatted it, created some directories on it and downloaded all the source codes and started compiling them. And yeah, this is pretty much where we continue right now. So put it in again. And I must remember to mount it because otherwise my script will start over and format it again. So yeah, I really should make sure that it is mounted. Okay. Okay, interesting. I think I might have put the USB key in a different USB port, so now it has gotten a different device name, so it's SDC now apparently. So now I have to do it like this. Okay. Let's make that sure. Yes. Good. So now we continue, and yeah, the next steps are pretty much the same as the last steps from the last video. I will just have script files for all the packages that we will use now. And this time we need the packages M4. You know what, I will not create them manually because it's a bit, that would be a bit much. I will do this like this. Chapter 6. And instead, because I will later need a list of these packages anyways, I will just create them in a loop now. So for p in, so the packages that we will need now are the packages M4 and curses, the bash, core utils, diff utils, file, find utils, GNU org, grep, gzip, make, patch, set, the stream editor, tar, xzip, bin utils, so we built the bin utils again, and gcc. Okay, so now I have created all these files here. In case you're wondering, if you don't know, I mean, this kind of came out of nowhere. These packages that I selected here, they pretty much, not pretty much, they correspond exactly to the table of contents of the Linux from Scratch manual. So as what you have seen: M4, ncurses, bash, core utils, diff utils, file, find utils, gorg, grep, gzip, make, patch, set, tar, exit, bin utils, and gcc. These are really the sub-chapters of chapter 6 in this LFS book, right? Okay, now I have opened the book in Ocula, but I should better open it with Chrome, because yeah, last time we I had opened it in Ocula, and that kind of broke the copy and paste. I don't know why, but whatever. So here we go again. Copy and paste all the code from the script, and this time it doesn't break the copy and paste. I think this one is a bit funny, that you build make with a make file. So you need to have make to get make. Okay, now we might want to hunt for cases where we have the version number of things in the script. You know, xz is 525, and in that package install script we set the variable where was it? Here. We set the version number. So we take the version number from the CSV file and store that in the environment variable version. So we might want to use that here. Of course, only in cases where that's relevant. Okay, so this looks good so far. Now we can do the same thing that we did with chapter 5, except now we have chapter 6. Then of course here we need to change this to 6 also, because now we are taking our scripts from the chapter 6 directory, and this list of packages isn't correct anymore. But I had luckily written that down already here, so I can just copy it from there. Okay. Now one thing that we should do in this package install script is we create the directory here, right? After we've determined the name for this directory. And I think maybe I should make this a bit bigger. Here is the name of the directory that we want to use, and here we create that directory. But we already had the bin utils in GCC in chapter 5, right? So these files will already be extracted, and when you look at something like M4, they do some changes to the files. So it would really not be a good idea to just, I don't know, if we did it like this, if we only tried to create the directory, this parameter -p means if it's already there, everything's fine. So yeah, this might lead to situations where you have changed some files in a previous run, and then you're using basically files from that have been changed, and you cannot be certain that the same change needs to be done again in the next run, and just this might just screw stuff up. So because of that, I will just test if this directory already exists. Okay. And actually the Linux from Scratch book actually advises you to do that anyways. So after you've compiled one package, they advise you to delete the directory directly and not wait for the next run through, but I think that's okay to do it here. Okay. So, yeah, we've already done chapter 5, right? So I will just comment this out for now, because, well, the stuff from chapter 5 is already compiled, and I don't want to compile it again. And everything else doesn't do anything, right? So it might try to create some directories, but they are already there, so that will just be ignored. The USB key is mounted, so this is going to be ignored. The download will just skip everything because everything is already there. Yeah, this is actually a good thing that we should execute every time we start our LFS script again, because we are running the scripts from the USB key, and well, if we had, we are editing them on the local hard drive, but running them from the USB key. So it's really a good idea to copy them over here so that they are up to date on the key before we run them. Okay. All right, this looks good. Okay, so I will start this. I'm actually curious to see what happens with M4, because I've had problems with that package when I tried this before, but I mean, I was able to solve the problems, but I have changed something in between, so I'm curious to see if this is going to work now. So Okay, 46. Okay, it's complaining that probably that nothing is done here. I will just put something that doesn't do anything in between. Okay, now it's compiling. Okay, so this is gonna take a while again, and I'm gonna have lunch now, so see you later. Okay, so this took quite a while. Yeah, I think I should look into the log files, because as I told you, I've had problems with M4 before. Oh, you know what, I will just take the whole directory. Yeah, M4 had problems as I had before. This is exactly the same problem that I have seen before. I had already written an email to the developers of Linux from Scratch, but they thought it was something I must have done wrong. I don't know, I think I followed their instructions very well, so okay, so yeah, we have this error here, and the compilation didn't succeed. So now I'm going to compile this again. It's actually a good thing that we have had a problem now, because it would be a bit boring and you wouldn't learn so much if everything just runs through smoothly, right? So the error message complains about a parameter WABI, which is a deprecated parameter, and they give they give an alternative for the parameter that you should give to the C compiler. So I'm gonna take that and yeah, if you know a little bit of make and the auto tools, you know that this variable C flags is there. Yeah, you can tell the make system to, or at least the if it's been generated by automake, you can tell it to give some additional parameters to the C compiler like this. Last time I did it, I also had fpermissive here, Although I think that should not be necessary because yeah, in my protocols from last time I did this, I've seen the compiler then complain that fpermissive is not even a parameter for C. It would be one for C++. So I'm a bit on the fence if I should put it here or not, because without permissive, I think this second error here might still occur. Again, the compiler had told me that fpermissive was not a parameter for it, so it might be a waste of a parameter, but I will still put it there just in case. Okay. So now I will only recompile M4. I hope that everything else will just run through. Actually, why I'm doing this in a loop doesn't even make sense. Okay. Yeah, I think this should work now. Oh, this was quick. I was just thinking about talking about the packages and what the reason for them and the reason why they are in there. But okay, it's already run through. A few warnings, but okay, so yeah, that was a bit quicker than I expected. Yeah, so then let's go to the next topic. Although at this point I want to make a backup of the whole thing. So the Linux from Scratch book also has some instructions on how to make a backup. So I will do that now. So you need to go to your Linux from Scratch mount point. And yeah, this tar command is kind of crazy, but I've tried it before, it works. So okay, so now while this is making a backup, this will take some time again. So then I promised you to go to the change root environment today. So I want to deliver on that promise. So yes, let's go there. So before we go into the change root, we need to do some preparation. So I created these two new scripts. Let's start writing these scripts here. So now most of these scripts I just invoke using this source command, and invoking it like that doesn't require them to be executable, but now these two scripts that I just created will be invoked in a different way, so they need to be executed. They need to be executable. So this prepare change root needs to be run as root. So we run this as with sudo, but we need to pass the LFS variable into the change root, into the script. We could actually do that doing it like this. Okay. Now, since I'm running this not from a source command, I have this shebang here. And since we are running this as root, we really risk breaking our working machine here. So so I'm taking the variable from the parameters, and I require this variable to not be empty. So just some just a sanity check to really make sure that we are not accidentally running this without that parameter. Okay. Now, we had created all these directories here, and all the directories except the sources directory now need to be given to the root user. And remember, we are running this shell script as root, so we don't need sudo in here. Okay. And again, this little thing here. Okay, so now we have given all the directories to root. If we run into problems after this, we'll have a problem, but it might be a good idea to have some script that does all this stuff in reverse, in the opposite direction. Okay. Now we create a few more directories. Namely the def directory, proc, sys, and run. And now comes a really interesting part of this entering the change root environment, because so far we've really just created some directories and ran some programs and downloaded some source codes and compiled them. But now this is really low-level stuff, because if we enter the change root, stuff might want to talk to devices. Like, I don't know, I'm not sure if the keyboard would even work without a def directory. I'm not certain, but anyhow, we just need the def directory. So we basically do something like a symlink. So we mount with the bind option. So here we've created the dev directory, and now we have something like a symlink or hard link from our original dev directory to that dev directory. Actually, no, it's not a hard link, it's a symlink, more or less, because hard links don't work across different file systems or between different partitions, and we are running this on a different partition, so it's not a hard link. Okay, then we do the same thing with dev.pts. If you're wondering, dev.pts is where the, on Linux everything is a file, at least in theory, and so your shells, like this console session here, must be something like a file also. And with the command tty, you can ask the shell, hey, what is your file? And we have the files dev.pts, and remember, pts is the directory that we are talking about here. Dev.pts contains the so-called pseudo teletypes. Okay, so this is pseudo teletype 1, and this is pseudo teletype 5. And now I could do something like echo hello and send that to dev.pts 5, and then it will show up over here. There's hello. And one thing, this is really just something that comes out and is then put on your screen, but it doesn't have any effect. So if I set something like echo hello, then this doesn't become anything executable over here. It's just text that you can see, but it's not something in your keyboard buffer or something that would have any effect if you send it out again. So this is really just something that came out of your shell as if it was printed by some program that you are running. This whole topic with pseudo teletypes is actually quite interesting. You might really want to look into that. Like there's, for example, the program screen, which is something like, how do I explain that? Screen can launch multiple shell sessions in parallel. So here we have, I've just created 2 sessions in this screen, and now I can do something in one of these sessions, and then Control A, Shift 2, go to the other session, Control A, and then you can switch between these multiple sessions. Now I've closed both sessions. That's why screen has now terminated, and now I've closed that whole session. Okay, so much about that. I digress again. This is but I just find that so fascinating. Okay, now we also need mk-not. We need node files for our console and for dev null with access rights 600 and 666 respectively. This is a character device, so parameter C, and then 5.1. These numbers are the so-called major and minor numbers, and yeah, you can Google for that, mk-not major minor numbers list, and there you will find, I don't know why this isn't the first result here, but this is actually part of the Linux source code documentation. So if you download the Linux source code, this is in the doc subfolder. Let me make that a bit bigger. So 1.3 is the null device. I guess you've already done stuff with that. For example, you redirect some outputs there just to suppress the outputs. And 5.1 is the system console. And this needs 666, the number of the beast. Yeah. Do you know these Octal access rights? So the first digit is for the owner of a file, second is for the group of a file, third is for any other user, and well, each of these digits can be any number between 1 and 7, or between 0 and 7 actually. These are octal numbers, and that means you have 3 bits to each of them. The first bit, the 4, that represents a 4, is for reading, so a read, write. The second one is for writing, and the third is for executing. So RWX is something I always have in my mind. So a 6 means 4 plus 2 means you have read and write access. 0 means the group and the any other person has no access. And here everyone has read and write access. Okay. So now we are almost done setting up the change root. We need to mount a few more things. The proc file system, it's there for communication with running programs, processes. I think PS and top probably use them in the background to find out which processes are running and stuff. So I think that's what proc is for. Then you need a sysfs. mounted to sys. Sysfs is for communication with the kernel. And then now the last thing we need to prepare the change root. That's actually something when I thought about making my own Linux system, before I looked into Linux from scratch, this is something I would not have thought of. What they are doing here is they are looking at the location def shm, and shm is shared memory. Why are they looking at that? Well, some distributions put that interface to shared memory not to def shm. They put it to some other location, probably run shm. But no matter where they put it, we just replicate that by if they put it somewhere else, this is a bit crazy to explain. If they put that somewhere else, then they will still have a symlink under the position def shm, and then we have to find out where does that point. And just have to create that file, and that then allows us to access shared memory. I don't know who found that out, but anyhow. So this is the stuff that we need to do as a preparation for the change root. And inside that change root, I will for now just echo test and pipe that to /test.txt, because in case anything goes wrong, I don't want to break anything, right? And even if we are not actually in a change root, then we just create this file text.txt somewhere on our drive, and then we will see, oh, something went wrong, because this is in the wrong location. So that's why for now I will really only have this for this inside change root. Okay. So we've prepared the change root now. Okay. How do we enter the change root now? Because now everything is there for us to work with. Well, sudo, because change root requires root permissions, not that's I think a given. So our LFS location is now going to become the new root. That's why I have this as first parameter here. And now I need to tell it what to run inside that change root. Well, we will run our bash you know, we've compiled our own bash and we want to run that. Let's log in. +H is to turn on history, so you can use the up arrow to return to commands that you've already given. And inside that bash, I will run this inside chroot script. Now where is that? That's at, it was at $lfs/sources/ inside chroot.sh, but when LFS is a new root, then this has to go away from here. Okay, and this is not all we have to do, because if we did it like that, we would not have any environment variables, and especially not the path variable, for example. So instead of running bash directly, we first run user bin env, which is a program that just sets environment variables. And we set the variables home equals /root, although that directory doesn't even exist yet. Term equals term. So I actually not. Maybe we should set this to bin bash, but whatever, I'll leave it like that. The path variable is where the bash looks for programs. When you enter a command, these are the paths that the bash checks to find the program that you're trying to start. Actually, did you know the program which? That's also a useful program if you don't know where a program that you're running is located, like which cd. Let's say which gcc. Which will tell you the location of, so if you launch GCC, this is going to be the location that it's been taken from. And it finds that really by just going through the path variable from first to last, and it finds a GCC in here, and that's why which then reports this as a location, and that's where GCC is started from. I digress again. Bin, user bin, sbin, user sbin. Okay. And now there's only one thing left that we need to do, or one variable left, and that's the variable ps1. And well, ps1, what is ps1? Well, ps1, now this doesn't tell you much maybe. ps1 controls this prompt, how this is formatted, and here this \open bracket, that's this bracket here. Then \033 is the start of a VT100 color code. these VT100 or ANSI escape codes, as they are also called, that's actually quite an interesting topic. So I want to tell you a little bit about it. Yeah, here on Wikipedia you can look into that topic. So these FE escape sequences are the interesting part. So it says here escape open bracket. And well, that's what we saw here, right? Backslash 033 open bracket. Now 033 is the octal representation of the ASCII character for the escape. You see down here. You might also see a 0x1b, which would be the hexadecimal representation, or even a decimal 27. Some systems also support something like backslash e for this character. So that's the escape. So we have here escape open bracket. And then that's the control sequence introducer. And then you have this list here which tells you what does the following stuff mean. And what did we have here? We had 01 semicolon 32 and then this M. And this M is the thing I'm looking for right now. So escape open bracket something M means select graphic rendition. Then down here it tells us what these numbers in between mean. So 01 is actually just a 1, so that's that means it increases intensity of the color, so the color becomes a bit more lighter. And then we had 32. 32 is in the range of set foreground color. So we have to look down here, and 32 is green. Yeah, that's what we're seeing, right? So this text here is green. And then later we set the color to color 37. 37 is white, and that's what we see here. And yeah, you can just play with this a bit. We can just change that variable. So I might just change the color in the front there to 33 instead, so then it's yellow instead of green. Or if I remove this one here, then yeah, it's not very visible, but you might see that the green is a bit darker here now than here. So you can do all sorts of stuff with that. So I might put some extra text in here. But okay, back to our topic. And then you get a backslash u, which is your username, at backslash h is your host name. Then they change the color from green to white. Then backslash w is the working directory. And then back to color 32, back to green. And backslash dollar is either a dollar sign for normal users or a pound sign for administrator users. So that's this PS1 variable. In the LFS book, they set it to LFS chroot user :working directory and either a $sign or £, depending on your access rights. So this will then run our inside chroot script inside the chroot. Okay. Okay, some status message in there. Okay. Okay, screw the backup. We're going live. We're doing it live! Entering change root environment. Hello from inside change root. That is looking good. That is looking good. So if everything has gone smoothly, then the parent directory of this, mnt lfs, should contain a file named test.txt containing just the text test. And there it is, containing the text test. So this was successfully run inside the change root environment. Yes! Great. This is one big step on your path to your Linux from scratch system. As I said, we might want to have some additional script which undoes all this stuff here, especially which gives the access back to our main user, or our LFS user. But yeah, for now I'm really happy, and I think this is now really enough for this video. So yeah. Great. So then that's enough for today. Tune in next time when we will build a few more tools for the for System B, and then we can finally really start building our final target system, our System C. And I'm really looking forward to that, so don't miss that. And yeah, if you like this video, like it, share it, subscribe, and maybe turn off your ad blocker. That would help me a lot. And see you next time. Bye.